K nearest neighbor. This is also one of the machine learning technique under the data science. It will also support for the supervised learning only. You already know what is the supervised learning. Whatever the data have with label data, if we have any data with label, that type of learning is the supervised learning. So this KNN, K nearest neighbors, it will be supervised machine learning model. It will use it for the both classification and regression, just like decision tree. Okay, in decision tree, what we'll do? First, we'll select whichever the attribute have high information. We select that is the root node. Then after we'll split based on the Gini index entropy. Here in KNN, what we'll do here? You people remember, I think, a cluster, unsupervised learning. That one is the unsupervised learning algorithm. Why? Because for that data, we won't have any label variable or dependent variable. What will do that one? Based on the distance between the one point to another point, we will group into the whatever the data points are very near each other. We'll group those data points into one cluster. Same like this. Here also, we'll take one of the data point and we'll choose whatever the nearest neighbors to make predictions. For example, the basic algorithm is first we'll store all data point as a training data set for each pattern in the test set. For the each pattern in the test set means, for example, let's take we have the 10 patterns in the training data, but we have the 15 patterns in the test data. What will happen? Whatever the 10 patterns existed in the training set, we are able to predict correctly for those 10 patterns which are available in the test data. But test data have the 15 patterns. What are the 5 patterns? These patterns information doesn't have in the training data set. What will happen for these 5 patterns? Our model fails to predict these 5 patterns correctly. So for that purpose, how many patterns are existed in the test data? For each pattern, we will store some data in the training set. Why? Because first we are trained well, then we are able to predict correctly. For that purpose, for each pattern in the test set, we need to collect training data. Then after, search for the k nearest patterns to the input pattern using the Euclidean distance measure. Here I mentioned Euclidean distance, but it's not mandatory to use Euclidean distance. There are so many other algorithms to measure the distance. How to select different distance methods? What will happen? Actually, I think there is no change. Whatever the algorithm or whatever the mathematical formula may be different, but the distance, whatever the method you can use, you will get same distance for the same distance between the 2 points. Okay, we'll practice by changing these algorithms, this Euclidean algorithm in the Python while doing the Python practice. Let's take here in decision tree, we'll take the parameters Gini index, entropy, information gain, gain ratio. These are the some parameters to identify the root attributes like that. Here also for classification, compute the confidence of each class as Cj by k, Ci by k. Here Ci is the number of patterns among the k nearest patterns belongs to the class I. For example, we want to get information about the some class I, whether it is I class 0, class 1, it's not a matter. But Ci, number of pattern among the k nearest patterns belongs to class I. We need to identify, for example, class I have the one pattern. For example, we have the only classes 4 or 5 in our dependent variable. But we have the at least 50 to 100 patterns existed in the training data. That means some of the group of patterns are belongs to one class, some other group of patterns are belongs to class 1, some other group of patterns belongs to class 2. So we need to identify CJ, number of patterns among the k nearest patterns belongs to class I. Out of the all patterns, how many number of patterns are belonging to class A? How confidently? Here we will measure confidence. Whenever new data point comes, we need to say based on the new data point pattern, yes, this data point pattern is belongs to this class. I am able to say this much confidence. Like the classification for the input pattern is class with the highest confidence. Whatever the class highest confidence. In logistic regression, what will do? Whatever the class get high probability, we will predict that is the class for this new data point. Just like that, whatever, for example, here we will calculate the, for example, we got the new data point. We will calculate the what is the confidence. This new data point belongs to class 0. What is the confidence? This new data point belongs to class 1. What is the confidence? This new data point belongs to class 2. Then after, whichever class get the high confidence, we will predict this data point belongs to this class. Same thing. That's the what happening in the k nearest neighbors algorithm. For example, assign a class to new data point based on its neighbors. That is the mode. Mode is means you people. I think you people remember in central tendencies I explained about the mean, median, mode. Mean is nothing but the average. Median means if we have the ordinal data, what we'll do? Instead, ordinal data or numerous data, whatever the continuous data. Sometimes due to outliers, mean gives the wrong information. At that time, what we'll do? Instead of taking mean value, we will ascending or descending our data points. Then after, we will pick middle number, whatever it may be. If it is the even number of data points does we have, what we'll do? We'll take middle 2 data points. We'll take the average of those 2 data points. If we have the data points with a odd number, what will happen? In middle point, we will get only 1 point. So we consider that is the median. Coming to the mode, what we'll do? For example, it is a categorical data. Categorical data, we can't assign like this ascending order, descending order. We can't sum and we can't do anything, any mathematical expression for the sum categorical data. At that time, what we'll use? Mode. Mode means, for example, we have the categorical data with names. We have the 10 names, but 2000 records. If we want to identify mode, what we'll do? Whatever the name most of times repeated, we'll take that is the mode for that categorical data. Like that, we will say. So, assign a class to new data point based on its neighbors. That is the mode. For example, how we are saying that is the mode. So, the name repeated more times. Like that, whatever the some data points very near to this data point. For example, this data point information. Yes, let's take the overall migration score. Overall migration score. How do we say whether it is a retain, retire, that one? Based on the score, we will say whether it is related to the retain, retire, some other. Let's take same thing here. This data point have the score. When if we want to build any machine learning algorithm, we will use the mathematical expression. For that purpose, whatever we got the new data point, we will convert into one of the mathematical value. We will do same type of conversion for the all the training data set. Whatever the mathematical value we got for the new data set, is what are the some other points which are already existed in the train data very near to this mathematical value, we will say this data point is belongs to that whatever the data points belongs to which class, we will say this data point belongs to that class only. So based on the nearest neighbors, identify numeric value of your new data point based on its neighbors. So whenever, for example, if how do we say patterns? For the categorical data, we can't apply any mathematical expression. That's why mostly what we'll use mode. That means whatever the data point repeated again and again compared to remaining data points, we'll take that is the one of the pattern like that. One of the more informative, more repeated information in that data point. Coming to the numerical, in numeric data, for example, we have the numeric data from 200 to 2000. There might be lot of values. There might be chance, for example, out of the 2000, 3000, 4000, there might be chance to repeat one or two one data point. So we don't need to go with a mode like this. Why? Because this is the numerical data. We can apply any mathematical function in this data. So based on the data, for example, let's take mean, where to take mean, where to take median. Here also, for example, whether it is the only integer, yeah, if does it have the outliers, we will go for the median. But it is not integer, it is the continuous variable. Continuous variable means there might be chance to be 0.5, 0.25, 0.75, 0.88 like this. So at this time, what will apply? Mostly we will apply the mean. Why? Because the mean have the average formula. Scientifically, it have the some algorithms for the average. That's why for based on the data, we will choose shall we need to apply mean or median. Weighted mean mode of entire data. For that means mean is nothing but here we need to consider mean or median for the numeric data, mode for the categorical data. So based on this mean mode value of entire data, we will take the decisions. For example, how to start, what to do. Let's see. Pick a number of neighbors you want to use for classification or regression. For example, first you can take some neighbors which are neighbors is nothing but here data points. Why they give means actually Python. Shall we anybody know why they give name Python for that programming language? That's the who are invented that one, that his interest. Like that, the K nearest neighbors means he's the whoever developed machine learning model. He gave that name based on his intuition, based on something. So here neighbors means I think he feels neighbors. Everyone know what is the meaning between the neighbors. So it is easy to understand. If what we say neighbors, we know about that at least to compared to unknown person, we know something about our neighbors. Yes? Like that, based on that similarity, some information about the one data point to another point, and some similar patterns between the two data points. Based on that one, these people are classified or applying classification and regression methods. And that's why here neighbors is nothing but the data points. So let's choose some number of data points for the classification and regression. Choose a method, measure distance, whether it is Euclidean or whether it is some other distance, whatever you want. You can use some distance to measure the distance between the some algorithm to measure the distance between the two neighbors. Two neighbors are two data points. Keep data set with records. Okay. How to choose K? Here is this is the main thing. In K means clustering also. We need to choose K before going to build K means machine learning model. Yes. Just like that, how to choose K here? You people, I think you people remember the cross validation. Cross validation. What is the cross validation? We will build different machine learning models by changing the training data set. Wherever we got the high accuracy and less error, we'll take that is the K value. Elbow method. Yes, same thing like this. Here we will use the cross validation. In elbow method also same thing. They are doing first they will consider K equal to 1. They build the machine learning model. They will calculate the what is the train accuracy, what is the error. Then after K equal 2, another model. K equal 3, another model. Like that till how many do we want to check? That many clusters it will check by calculating the error. So same thing. K is 1 is good baseline to benchmark against. A good rule of thumb, K should less than the square root of the internal number of training patterns. K is 1 is good baseline to benchmark against means, for example, we are considering only one neighbor, which are very near to us. For example, if let's take, if we want to inquire, we are applying for the some visa, everything, what will do? Police will come and they will check whether he is good guy or not, whether he is living in this area or not. Does he have any uh, remarks like that? First, whom they will ask? Whoever living near to him, near to his house. Why? Because uh, these people who are near to him, that man have the high information about this guy. So if we consider which data point very close to the class 0, if we have taken that is the example, whenever new data point comes to that data point, we are able to say this with a high confidently this data point is belongs to that class. If the some patterns are very it's not near to it, K is not 1, here the 3 or 4, that means there is some distance between this pattern to that class. There might be chance some by including some more distance, there might be chance this pattern belongs to some other class also. What will happen at the time? There might be chance to be a misleading. The confidence level, if we want to say this data point belongs to that class, the confidence level will be decreases. So we need to choose K as much as less. Sometimes this is the rule of thumb. For example, uh, in training dataset, we have let's assume we have the 10 different patterns. It is better to take K, which is the square root of the training patterns. That means less than the 10. Less than the 10. Why? Because what is the square root of the 100? That is the 10. So it is better to take K value less than the 10. Okay. For every new point, identify the number of nearest neighbors you picked using the method you choose. What we'll do first, we'll take one data point which is very near to class 0. Then after what we'll do, we need to identify number of nearest neighbors. Out of the number of nearest neighbors means number of data points which is very close to that data point which is belongs to class 0. Using the method here is nothing but the distance. We are measuring only distance. We have the different algorithms to measure the distance. There is the one algorithm, cosine similarity, Euclidean distance, some other. So whatever you choose, that's your opinion and your choice. We need to identify the nearest neighbors to that particular class. Let the vote if it is classification issue or take mean median for the regression issue. Why vote? In classification issue, that is the dependent variable is always categorical. So shall we able to apply mean median for the categorical data? No. What we'll take? We'll take the mode. Mode means highly repeated value. That means whoever get the high votes, we will say that this data point belongs to that class. Why? Because that class got the high votes. For the regression model, we will use mean and median. For example, you know the linear regression, that is the straight line. By using straight line, we are able to predict house price or some other. For the classification model, what we'll do? Sigmoid function. We'll take sigmoid function. We'll put one is the threshold, that is the 0.5. So we will calculate probability based on the probability. This we will compare with threshold. We will identify whether it is belongs to class 0 or class 1. Coming to the decision tree, what it do? Instead of splitting two classes into one line, it will split by using the another lines. For example, here class 0 is available. Remaining part, everything is the class 1. What it will do? Based on the one line, it won't able to split class 0 and class 1. At that time, what it do? It will horizontally cuts one line. Then after it will splits with one line here, with one line here. So the data points comes under this circle, that is the class 0, remaining are the class 1. Just like that, based on the nearest neighbors, this KNN also splits like this one. First, what is the decision surface created by KNN? This is this diagram in hierarchical, what we call it as a dendrogram. For the K means, that is the K means decision tree, name itself that is the tree. Like that, this diagram is the Voronoi diagrams. Each point in convex hull is close to the sample inside the convex hull than it any other sample. For example, let's take this is the convex hull. What is this? We call it is the convex hull. The sample inside the convex hull than any other sample. This means whatever the data points under this convex hull is the very close than compared to the other convex hull. Then compared to the other convex hull. For example, let's take here we have these are the some data points. This is the one convex hull. Let's take that these are the some boundaries or neighbors of this data point. If we have considered this data point is very close to 0, whatever the data points very close to this data point, those data points also belongs to class 0. Yeah. But here the thing in decision tree, we will split like this one. But here we are giving convex hull for the each and every data point. So it is more complex than decision tree, for example. Then after, what will it do? Non-linear decision boundaries. Actually, we can't split this one with a linear regression like this. So if we want to put like this, very near. So there is a lot of non-linearity presented in the data. What will happen? Can be used to deal with very non-linear data, unlike linear or logistic regression model. We have the one problem with non-linear data. So we can't apply linear logistic regression. At that time, the complexity of space grows, accuracy comes down. You need to more data. The complexity space grows means, for example, let's take this is the data. What will happen if available here? This if this red point comes here, what will happen? It become very typical to classify the two groups. So if the non-linearity or complexity space grows, yes, automatically our accuracy also become down. So increasing K can reduce the overfit. There will be an optimum K. Actually, by increasing K can reduce the overfit, but there will be an optimum K, but we need to take less K. Why? Because,
Ma'am, I have one doubt.
tell me.
Ma'am, in this diagram, the red one, it is telling about the data points, okay,
Yes.
which are very close to each other. That is okay, fine. But the thing is, what that blue triangle is telling about.
Blue triangle is one class related data. This red color is the belongs to another class data.
Okay,
Okay. So if actually these whatever the in red color, these are belongs to class 1. Whatever the blue triangle, these are belongs to class 0. So whenever we want to build a model, what we need to do? We need to identify something like this to differentiate these two. What will take? This is the boundary for these two classes. Whenever new data point comes, we will calculate the distance between this boundary to the data point. Again, this boundary to this data. What the data point to this data point data. Then after for this one, both sides. First, we'll check whether
okay,
that data point comes to the blue like this. Then after whether that data point comes to the red group. For the which class we get the high confidence, we will say that data point is belongs to that class.
okay,
Wherever, whether it is the linear regression, whether it is the logistic regression, whether it is the decision tree, whether it is the KNN, we need to identify the boundaries like this. In linear regression, we will have the line like this. What we'll do? Whenever new data point comes, we will measure whether that data point lies under that line or near to that line. If it is lies on that line, so that is the good prediction. The data point lies above the line or below the line. What will take? We will take the distance between that data point to that line. That is nothing but the error. That is the linear regression. Here also we need to find some boundary like this to differentiate between the two classes. Based on if the data point, what we'll do, for example, let's take, the number line. Between we will assign the zero value. Right side all are plus values. Left side all are negative values. Whenever new data point comes, that zero is the differentiation between the positive and negative values. Let's consider like that. This boundary is the zero. Whenever new data point comes, first we will check whether that point is the positive number or that point is the negative number. If it is the positive number, what we'll say? We will assign that data point to the positive side. Whether it is the negative number, what we'll do? We'll send that point to the left side on the number line. Same thing. If this is the boundary, if the new data point comes, if that point have the whatever the value we get for that point, that is belongs to red, we'll say this is the red cluster. Otherwise, we'll say it is the blue cluster. Whatever the data point, whatever the new data point comes, we will convert into the mathematical sum of the vector, some value. Finally, we will get the 1 by value. Whatever the how many independent variables does we have, that's not a matter. Y equal beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 till beta n xn. By using all variables, we will calculate 1 by value. If that value is near to blue, so we will say that value, that data point belongs to blue cluster. If that value is lies under red cluster or very near to red value, then we will say that data point belongs to red cluster.
Okay.
So issues with KNN is, if we have the outliers, what will happen? If we have the lot of features, what will happen while calculating nearest neighbors? If we have the high dimensions, whenever we increase dimension, what will happen? We are able to separate one data point to the another data point. Yes, for example, if we have the two dimensionality, what will happen? Some points lies on the overlapping with the another cluster. If we are using three dimensional, what will happen? We are able to separate those two clusters on the third dimension. So by increasing number of dimensions, what will happen? The distance between the one point to another point will also increases. That's why, but if the distance between the one point, here we are applying concept that is the nearest neighbors. If we are increasing the space between the one point to another point, what will happen? There might be chance to miss identification of the nearest neighbors. That's why if require more time for the prediction, more memory also. Why? Because let's take for the decision regression, we will build one line like this, then after one line like this. That's it. But here see, to giving this is very complex than the decision tree or linear regression. Just like random forest. Why? Because random forest makes the number of decision trees. Like that, it will take the nearest neighbors for the each and every data point separately. So due to that one, it takes some more time. But how to deal with that, we'll explain. Till now concept, do you have any, don't worry, it's not completed yet. There may be some more time it will take to complete. But you have any doubts, you can ask.
No.
Yeah, we'll get some more information here. For example, what are the some attributes we need to consider while going for the k nearest neighbors? That is the scaling the attribute is important. Why? Why we are scale? Why we need to scale? For example, some data points comes with CJs. Why I am repeatedly saying with the CGS method, with SI method, some data points within the centimeter, some data. For example, we have the some measurement with centimeters, some measurement with kilometers. What will happen? The measurement which is, for example, we are doing some project on the OS versions and applications. What will take? We will take the space, RAM or CPU usage and some other, for example, does it have the databases? We have the RAM with bytes, E drive space with kilobytes, E drive space with kilobytes, some other C drive space with megabytes. Compared to gigabytes, megabytes, bytes value is very high, right? For the 1 megabyte, we will get the 1024 kilobytes. The difference between 1024 to 1 is the very high. But compared to 1024 megabytes is the very high. But the if we have the data in different scales, what will happen whenever we try to calculate the nearest neighbors? The values between the distance between the two values may be become very large. If we are scaling those attributes by using range or standard scalar, what we'll do? We are converting entire values into the 0 to 1. After scaling, you people can observe the values converted into 0 to 1. So all values, which are the bytes, which are the kilobytes, which are the megabytes, which are the gigabytes, will come under same scale. Will come
Okay.
under same scale. Why? Because for to store the database, we are storing into the gigabytes. We won't use kilobytes, megabytes like that. For the coming to the RAM, shall we use that many gigabytes RAM? No. So we need to measure in this way only. For that purpose, if we are scaling, we are giving the same importance for the everyone. So before going to apply anything, it is better. I won't prefer scaling is only for the PCA, scaling is only for the decision tree. It is better to apply this scaling or standardization normalization method for the before going to build a model. Why? Because it will avoid some outliers, it will avoid some random noise, it will avoid some scales, what is the some different value, some fluctuations in the data. Okay, attribute which larger range can dominate. Larger range means for example, does it have the let's take the kilobytes. For example, age lies under between only 20 to what is the range? Mostly we'll take 0 to 100. More than that, no one can live. Some people who who got the high years of life within the crore, maybe one or two people will live more than 100 years. So 0 to 100. Let's take high range can dominate. For example, you people remember that PCA. What we'll do? Whatever the data points have the high variation, those data attributes are dominant principal components. The attribute which doesn't have any variation or very less variation, this is the irrelevant or irrelevant redundant principal components. What we will select to build a model? Always we need to select which are have high variation. Those are the dominant principal components. Those attributes we will choose to build a model. Like that, whatever that range means, the starting minimum value to maximum value is very high. So the range within the, for example, let's take the numerical data. It have the 100 to 1 lakh. The range to lies for that attribute is the 100 to 1 lakh. So that type of attributes will get the high dominant. Why? Because it is easy to measure there might be a lot of space between the one data point to another data point. Due to that, it is easy to measure the nearest neighbors. Like that, categorical variables and ordinal variables need to convert it to numerical. I already told you so many times, whatever the machine learning algorithm, it depends on the scientifically science and mathematics. So we need to convert our categorical ordinal data into the numeric. Why? Because here everything, how do we are calculating the which class this data point belongs to which class using the distance. How do we apply this distance? Whatever the algorithm, That is the mathematical algorithm. So we can't apply that algorithm on the categorical data. That's why we need to convert into it as a numeric. Think distance with respect to target. Always we need to check what is the distance between the target, whatever target class to the this data point. Then only if this data point have the very less distance to this class, then we will assign this data point is belongs to this class. If it is very far to this class 0, let's take the class 0, then we will check what is the distance between this class to class 2, this data point to class 2. Like that, we will go for. KNN is heavily impacted as all points are at the surface are hence similar. Yeah, all points are at the surface are hence similar. For example, in this diagram, if is there any data point, which is lies on near to boundary here in boundary. For example, these are the two. These are the surface areas boundaries. If data point belongs to here in these places, we typical to say whether it is belongs to red cluster or blue cluster. That is what they are saying here. Surface are any similar, impacted, highly impacted with those all points. At that time, what we need to do, reduce the dimensions by using the correlation or information gain, whatever the measurement we need to choose. How do we do, Wilson? These are the wrapper methods. Those are the forward selection, backward elimination. We will these are the two separate concepts. I will explain in coming sections. Just like bias variance, these are the two different concepts, forward selection and backward elimination. We'll say those concepts in coming sessions. Weighting attributes. This is GARS of dimensionality means dimensionality reduction. How do we reduce the dimensions? By using the PCA. So think PCA. You can remember or you can recall PCA once condensing. Here I said feature selection, backward elimination. Due to that, what will happen? Let's check. This is the original data we have. This is the condensed data. This is the minimum consistent set. What is the difference between these one? We'll explain here. Aim to reduce the number of training samples, retain only the samples that are needed to define decision boundary. Aim to reduce the number of training samples, retain only the samples that are needed to define decision boundary. There might be some points. For example, let's take these 2 points, and these 2 points. These are the 2 points which are giving some confusion while setting the particular decision boundary. Yes, these 2 and these 2. This is the blue cluster, this is the red cluster, or this is the red blue group, this is the red classes. You people know about the class. That's why I'm saying in that terminology. This is the blue, this is the blue. These are the 2 points and these red point and this red point. Due to this, we are not able to split with the line correctly. So we need to reduce those number of training samples, retain only samples that are needed to define the decision boundary. If we don't have these 4 points, what we will say? We will draw one line like this. We are able to say which are data points above this line. Those are the blue class. What are the data points below this line? Those are the red class. Those are belongs to red class. So we need to reduce this type of some training samples by increasing more data or by adding some more features. Decision boundary consistent. A subset whose nearest neighbor's decision boundary is identically to the boundary of the entire training set. That is the condensed data. So we need to decision boundary consistent. A subset whose nearest neighbor's decision boundary is identical to the boundary of the entire training set. So if we can't do, actually we are able to draw one line. So we can't like this one. This like here under this one line we have the 3 lines. So instead of that, we need to write something, we need to build some boundary which is very identical like this. So this is the one of the condensed data. Minimum consistent set. That is the smallest subset of training data that correctly classifies all the original training data. That one is this one. So instead of doing these all clumsy, by taking one training data set, we will draw line like this. So to compare like by checking like this each and every data point, it is easy to. For example, if data lies here, what we'll do? For example, what we did like this. One data point comes, that is the blue data point. It lies under here, near to this boundary, but this side, red side. What will happen? It will become misclassification. Is it right? If we are doing like this, what will happen? There might be chance if is there any blue point lies here, is there any red point lies here. What will happen? The classification will become very,
Confusing or
yes, there
misleading.
may be a chance to misclassification. If we did like this, what will happen? Whatever the data points near to this boundary, whatever, for example, here to here, it will belongs to red only. But let's take here red, where if red lies here, that's okay. If blue lies here, this is the line we draw here actually. If blue one is here, what will happen? It will become misclassification. For that purpose, we need to take minimum consistent set. Consistent means whatever the training samples clearly, with clarity clearly, with high confidence, we are able to draw boundary. We are able to build boundary to classifying correctly. Here, the small subset of training data that correctly classifies all the original training data. That type of data set we need to prepare. Condensing. Condensed nearest neighbors. That is the CNN means convolution neural network. Mostly we use actually after this machine learning models, we will go for the deep learning. At that time, we will explain about the neural network. This is something here the explanation. First, you can scan all elements of X, looking for an element X whose nearest prototype from U has the different label than X. First, what you need? First, you can scan all the elements of X. X is nothing but data points. Looking for an element X, let's take the while looking one data point whose nearest prototype from U. That means who are very near to U has a different label than X. What will do? But which is near to you, but the label of that one is the other one. That is the X. For example, let's take here blue one. It is very near to red. Yes, is it right?
Yes,
It
ma'am.
is very near to red. But what is this one label? Blue.
Yes.
Label is blue, very near to red, but label is that what the concept it is saying here. Scan all elements X, looking for an element X whose nearest prototype from U. It is very nearest prototype to U, but has the different label than X. But the label is not your name. So remove that X from X and add it to U. What you will do? So whatever the misclassification, you can try to remove that data point and you can assign that data point to U. Instead of saying other label, you can say that is the U. Then after repeat scan until no more prototypes are added to U. So U is the condensed subset. That means what we will do, whatever the data points which is try to misclassification, you can separate those all data points and you can assign that data point into the condensed data. Then after X is the entire data set, U is the condensed subset. Condensed means which are misclassified, which are actually belongs to other class but very near to the another class. So by removing this one, what will happen? Like this, we are able to separate these two red and blue clusters like this one. Clusters means classes like this. That's what. Instead of this one, sometimes like this. Here, what will
Okay.
happen? Yes, if we did like this, if is there any red point here, there might be chance. But if we are able to like this one, why? Because What he said, repeat the scan until you no more prototypes are added to you. That means here you added this blue point. Here what will do? Here whatever this one red very near to blue but have the other label. So you can assign this point to the condensed data set with label. If whenever new data point comes, if you are not able to identify by using these, by eliminating these two information, you will check whether that one belongs to this one or this one. If you are not able to predict correctly at that time, by using this condensed data set, we are try to identify whether it is belongs to class G, class red or class blue. Got it?
Okay, yes, ma'am.
Yes. The data set reduction editing. How is this diagram? How is the classes? How does it linear data set? Does it non-linear data set?
Seems like this is non-linear.
Yes, non-linear. We can't split with the linear line.
Yes.
Here, the data contain lot of noise. Let's see why I am saying noise. Let's take this one data point, right? Whatever the data point near to that red one, all are blue. So we need to create one convex hull for this one to identify this cluster. Here, for example, you can take this one also blue. The nearest points are red. So we need to create one decision boundary for this blue one. So training data may contain noise and overlapping classes one on the other, starting to make assumptions about the underlying distributions. So, in this classification, this condensing method also not used. We can't apply this one. How do we eliminate? What to do? Yeah. Here we need to reduction data set. That means we are have the lot of data which are very high noise. What we need to do? We need to edit our data to by reducing for the feature selection. Let's take most of this line. Okay, most of the red lies here and here. Okay,
Yes.
the remaining are the noise. We are not able to classify correctly. So we need to reduce these data points. What are the blues here? Whatever the blues here? Whatever the reds here? We need to edit data by reducing the data set. So here
Okay.
training data may contain noise overlapping classes like this. Editing seeks to remove noise points. That is the noise points. Which are the points? Uh, Try to misclassify the whether it is belongs to blue class or the red class. You can remove those noise points and produce smooth decision boundaries, often by retaining points far from the decision boundaries. That means we need to, for example, these are the all blue points. So we need to eliminate these 5 red points. Here also all are blue. There are some 7 or 8 red points we need to reduce. Here also all are red. If you can eliminate these points 6 or 7, so it become red cluster like that. So we need to eliminate, remove some noise points to produce the smooth decision boundaries like this one and like this one. Yes. If we create one boundary like this one by eliminating these blue points. If we draw one decision boundary by reducing or removing these blue points, we will get the good data. So here that is the main concept. Here we want if the non-linearity present in the data, to eliminating the some random noise, what we need to do? Whatever the attributes which are caused for that random noise, we need to eliminate those attributes. Whichever attributes have the random noise, we need to eliminate those attributes. Due to that, we are able to convert nonlinear data to the somewhat of linear data. It's not possible to completely convert nonlinear data into the linear data. But by reducing that random noise, we are able to reduce some nonlinearity in the data. Then we are able to define whatever the decision boundaries very smoothly. We will see this one under the Python practice. See. Use K that gives the least error on the test data. This is what I said to you in the cross validation. First, you can give 1 to 10. 1 to 10 to make the decision about the K. For example, sometimes if whenever we use K, it may be error very less. By increasing K, error will goes increases. Sometimes for the one, whenever we assign K, 1 for K, the error is very high. By increasing K, it will be decreasing. But we need to draw, that is the convex one like this. Wherever the error is very less, we need to give that is the value for the K. What here we are doing? Here we are checking K from 1 to 10. What we'll do? We will build one model by using K is equal to 1. We will calculate error. Then after by assigning K 2 to the K, we will build model, we will calculate the error. By assigning 3 to K, we will build one model, we will calculate the error. Like that, we'll repeat same steps till by applying 10 value to the K. Wherever the model error will very less compared to other models, we'll take that is the final K value to build this model for the good results. At that K value only, we will get the less error and high accuracy.
Okay.
Yes. This is the how we choose K value. Missing values. Handling missing value is also one of the important skill. Some people, for example, we have the values 200 to 300. There are, we have the 10,000 records. Out of the 10,000, 10 records are very, doesn't have any information. What we'll do? We blindly fill with 0. What will happen? Suddenly, the distance between actual data points are lies between the 200 to 300. So if while going like this one, there might be one value that is the 0. That means what will happen? It comes like this here. It will actually it goes like this one with some variation, but sometimes wherever we fill with 0, it comes like this one like this. So what we call this is the noise. So instead of filling with 0 or other values, we need to first identify whether that attribute is categorical or numerical. If it is the categorical data, it is better to fill that missing values with mode value. Mode value is most repeated category in that categorical variable. Whether it is numerical data, it is better to replace that value with mean or median. That is also whether it is mean or median, that is also depends on the outliers presented in that data. If the data doesn't have any outlier, you can apply mean. If you observe a lot of outliers in that particular attribute, you can apply median. So the handling missing values also important. Imputation is one option that might be self-defeating. Imputation means this is the one of the method that is nothing but to identifying it. It will automatically identify whether it is the categorical data or numeric data. Based on the data type, it will replace missing values. It will replace missing values. That is the concept is called imputation.
Okay.
Yeah. This is actually till now I have explained concepts. Now we'll see how to start, how to go for the predictions. First thing is the data collection and preparation. First, we need actually this KNN is the supervised learning. That means we need to collect labeled data set, meaning each data point is associated with the class label, whether it is the class label or whether it is the numerical value or regression. So the algorithm uses the only labeled data. Why? Because this is supervised learning algorithm. Then after choosing value K. K is the main hyperparameter we need to set before going to build model. It represents the number of nearest neighbors that we'll consider when making predictions. That means For example, you can take one data point which is very near to class 0. Whenever new data points comes, we'll check whether, for example, I gave the k is 3. What we'll do? For example, let's take this h is the k value. This h is the class 0 data point. Whenever we give k, k3, what will it consider? Y, P, E. These are the 3 nearest neighbors to this class. What will check? Whether the given data point is belongs very near to H. Then after it will check whether it is very near to Y. Again, it will check whether it is very near to P, and again whether it will check whether it is very near to E. If that data point is near to any one of these 3 neighbors, it will assign class H for that data point. So if you gave only k equal to 1, it will check whether that data point is belongs very near to H and Y. If it is near to Y, it will say that is the class H. If it is near to P, it will say it is not belongs to class H. It will check whether it is belongs to other group or not. Like that. So the classification or everything is depends on the value what you have chosen for the k. That's why k is very less. That means we are able to find whatever the neighbors which are very close to the class. If we are increasing k, what will happen? For example, here R is 1 class, H is 1 class. I gave the k equals 6, 4, 5, 6. Here 1, 2, 3, 4, 5, 6. If is there any data point lies in between here, what will happen? It will not identify. For example, which is the point belongs to R, which is lies under R. Here also R. This is also R. This is also R. If the data point comes here after P, what will happen? We have taken K5, K6. Sorry, 6. 1, 2, 3, 4, 5, 6. So the data point which is lies between P and A, that is actually belongs to the R. But by taking K equal 6, our model will predict it is belongs to class H. So that is the confidence will be decreases. Why? Because the distance between this H and this A is very high compared to this H and YPE. So it is better to take less K value to predict accurately, to increase the accuracy. A larger K help to smooth out the noise in the data, but it can also make algorithm less sensitive to local patterns. It will increase by because if they actually, let's take this is the one cluster. If the data points noise which is here, here, here like this, by increasing K, it will able to handle this whatever the random noise. But here the problem is something that is the sensitive to the local patterns. Is there any other patterns which are belongs to other class? It will be fail. The noise is belongs to other class. What will happen? Our model accuracy will become reduced. Calculating distance. So here I am saying whether k is the 3. What will check? How it will check whether it is near to this YPE or not by using the distance measurement. So whatever the algorithm calculates the distance between that point to the all other points. But whatever the distance metric you use, that's up to you. You can use Euclidean distance, you can use cosine similarity, you can use Manhattan distance, whatever method you want to, you can use. It's up to you. But we need to use one measurement to calculate the distance between the one data points to all other data points. Then after selecting nearest neighbors, the k data points with smallest distance to the given data point are selected the nearest neighbors. That means the k data points which are very near to the given data point. For example, these are the k data points belongs to some class 0. If the given data point is very near to these k data points, what will say? This data point also belongs to class 0. So to selecting these nearest neighbors is the one of the main thing we need to do by using our machine learning model. For the classification regression, what we'll do? For the classification, we will calculate the mode value. For the regression, we will take the average. We will take the average. For the classification task, the algorithm assigns the class label that most common among the k nearest neighbors. That means this is the data point. We are calculating the all data points which are near to this data point. For example, let's take this one, this blue color. This is the new data point. Let's assume. What we'll check? We will check the all other which are near these five. These five are six. Okay, very near to this data point. Then after we will ask which color, that means which class got the high votes. Let's check what are the votes. These are the six data points very near to here. Here, out of these six, two are red, four are blue. So, which class got high votes? Blue class. That's why we will say this data point belongs to the blue class. Like that, whenever new data point comes, first we will check what are the nearest data points to that data point. Then after we will ask each and every data point, will you belongs to class 0 or class 1, class 2? Then after finally we will take the mode of the results. The regression model, what we'll do? We will calculate the average of the all things. Based on the average, we will give the one numerical value. For regression task, it calculate the average or the median of the target value of the k nearest neighbors. Same thing. Previously we have selected most repeatedly color. Now class. Now we will calculate the average. That's it. Then after whenever new once model building completed, whenever new data point comes, we will make the predictions based on these nearest neighbors only. Once the class label or numerical value is determined using the nearest neighbors, it is assigned to the prediction for the given data point. Whether it is classification based on the words, it will predict whether it is the class 0, class 1. If it is the regression model, that means numerical data, it will calculate the average value. It gives the, for example, our dependent variable within the 10 lakhs to 20 lakhs. We will calculate the average, whether it is the 50%. That means we'll take the average of that entire 10 lakhs to 50 lakhs. We'll take the average value. We'll assign that 50% to that one. That value is it will predict automatically that value. For example, we have the data points 10 lakhs to 20 lakhs, let's assume. We have calculated what is the average value we got, that is the 0.70%. What will it do? It will say the house price is might be 17 lakhs. It will assign that 70% for this 10 lakhs. That is the 17 lakhs. If we got the average value 40%, the house price might be 14 lakhs, like that. Based on the average, it will calculate the regression value. Every machine learning model has some pros and cons. So based on the advantages, disadvantages, we need to select whether this machine learning model helpful for this case study or not. It is very simple. Advantages are it is very simple and easy to understand. No training involved, new data points can be added easily. Can work well for the relatively small data sets. This is the good thing. Actually, whenever we go for the real-time data, it is very difficult to get the large amount of data. Mostly we will get very less amount of data. But this k nearest neighbors works very well on the small data sets. But coming to the disadvantage, computationally expensive. So we need to calculate the distance between one data point to all other data points. So it takes lot of calculations, needs to calculate distance for all data points, sensitive to irrelevant features. That is the if is there any noise presented that one. So those noise data are very far to these data points. To measuring that data points, whether it is belongs to which class, it is very typical. Choosing right K can be challenging. So we need to apply cross validation for the out of 10. That means before going to build model, first, if we want to choose K, we need to build 10 models. Yes. First, we need to build 10 models. We need to check error. Based on the error, we need to choose some K value. Then after, by using that K value, we will build our final model. So before going to build model, to choose the K, we need to build 10 models. That means it will take lot of time. It will take lot of computational computational complexity. So that's the problem with K-means and KNN also. If it is work very well for the small data. If we have the very large amount of data with a high dimensionality, what we need to apply dimensionality reduction technique. That is the curse of the dimensionality. These are the some advantages and disadvantages of the KNN. Does you people have any doubts? You can let me. Will clear.
There was one point that is you said about the scaling the attribute is important.
Yes,
So
scaling.
scaling, yes, in that it is the same, right? If we have taken very high as 1 and high as 2 and low as 3 and medium as 4, something like that, to calculate it in the inside the model for the calculation purpose, because we can't calculate very high, so we have designated it
Yes,
as
we
1.
need to encode. We need. That's what I mentioned that point also. We need to convert categorical data into numeric data. Why? Because here we are calculating the distance between the one data point to another data point.
Yeah. So that is the same concept, right? About the scaling also, scaling the attribute.
Scaling means, for example, no, the scaling is different. Actually, the data points, for example, house price prediction, you can take that is the 10 lakhs to 20 lakhs.
Okay.
But the some other parameters, 2 BHK, 3 BHK, those are the 1 to 4 or 5. Some other square feet, that is the 1000 to 11,000. The distance between actually measuring the distance between these doors, these 1 BHKs, these square feet is very less. After scaling, what will become? It will all points will become under 0 to 1. Whether it is bedrooms, based on the number of bedrooms, it will assign value 0 to 1. Based on the square feet value 10,000 SFT, sorry, 1000 SFT, 1100 SFT, 1200 SFT, it will assign values 0 to 1. For the house price
Okay.
prediction also, it will assign value 0 to 1. That is the normalization. Is there any, for example, if there is outliers, uh,
Hmm.
1000 to 2000 we have the values, but there is might be 4000 5000 values. While normalizing this one, what will happen? It will assign 0 to 9 for the 1000 to 2000. For 1000 to 2000, for the 1000 0, for the 1100 0.1, between the 1000 to 1100 and 0.01, 0.1 to 0.13, 0.14, like that. For the outliers, it will assign 0.9 to 1. Like that, it will scale the all the data. So the random noise over outliers will become normalization. That is the standardization, normalization, or the scaling.
Okay.
Okay, anybody? Okay, guys, thank you.
Thank you, ma'am.
Thank you, ma'am.